Hi, I'm Mike Claron. I'm on the Android team. I manage the System UI Framework and UI Toolkit teams there. We're going to be talking today in a lot of detail about some big changes to how we recommend that you build Android applications. But before we go into a lot of the details, I thought it'd be helpful to step back a bit and frame the discussion by talking about where we came from and where we're going. So let's do that. So to start, Android has always been based on some strong principles. Not surprisingly, those were best expressed by Diane Hackborn. She's the one who actually architected most of the Android framework. She wrote a post about this a few months back, and I have some excerpts from that here. If you look at our core primitives, activity, broadcast receiver, service, content provider, you might reasonably think that those constitute an application framework. But that's not the right way to think about it. These classes are actually contracts between the application and the operating system. They represent the minimal amount of information necessary so that the OS knows what's going on inside your app so we can manage it properly. So as an example, if your app is running in the background, but it's also exposing data to another application through a content provider, the OS needs to know that, and we need to know that so we don't accidentally kill you. The content provider is a mechanism that tells us that so that we can keep you alive. So we think of these core classes as really being like the fundamental laws of physics for Android, hence the illustration. That is the cover of the manuscript where Isaac Newton first presented the basic laws of motion. Now, fundamental laws are a good thing. I use a shorthand when talking about this. I say Android has good bones, even though people look at me funny after I say that. But what I mean by that is that Android is based on a small, stable, cohesive set of core primitives, and that allows a common programming model across a really incredibly diverse range of devices, from wearables to phones to tablets to TVs to cars and more. This model also gives application developers the freedom to choose whatever framework they want inside their application for their internal framework. So that means that we on the Android team don't have to get involved in debates about whether MVC is better than MVP or whether MVP is better than MVVM. You guys can pick whatever makes sense to you. Now, that's a pretty good story if you are in the operating system business, like, say, me. But if you're in the app development business, like, say, all of you, that's really only chapter one of the story. And the reason for that is because while strong fundamentals and freedom of choice are good things, we know that in your day-to-day jobs, and we know this because you told us, you want more from us. So I'm going to abuse my analogy a bit here. We can all appreciate the simple elegance of Newton's laws of motion, but if your job is to land a rover on Mars, you don't want to come to work each day and start with only F equals ma and derive everything from first principles. So we've been talking to developers both inside and outside of Google and taking a hard look at the app development experience. And we've realized a couple of things. First, there are peaks and valleys. Some aspects of app development are better served by our APIs than others. For example, we think Recycler View is at the better end of that spectrum. So with Recycler View, we didn't say, hey, we give you events, and you can draw stuff, and in between you have a Turing-complete language, so good luck with everything else. On the other hand, maybe activity and fragment lifecycles belong down in that dark, shadowy place, because there, I think, too much of it is indeed left as an exercise for the reader, and we want to fix that. So as we thought about this, we realized a good solution has some key properties. First, we have to solve the right problems. This is going to be a sustained effort, like sustained for us on Android. But for the first cut, we want to make sure that we're going after the problems that every developer faces, the things that are hard to do right now. Again, app lifecycles is a really good example. If you don't get that right in your app, nothing is going to work on top of that. And that's true for your app, but that's also true for the frameworks we're trying to build. We have to get that right before we can do anything else. Second, we have to play well with others. We know that you all have huge investments in your existing code bases, and we can't create a model where the first thing we say to you is throw all that out and start over. So we're trying to create APIs that you can adopt a little bit of it at a time, and also that interoperate well with other libraries or other frameworks. Third, we want to be more opinionated. We want to take a stronger, clear stance on how to Android an app the right way, at least as we see it. Now, this is all still optional, and if you already have something that works for you, then great. But developers are telling us that they want more guidance on how apps should be built. And by the way, we're not changing any of the laws of physics here. We're just layering some higher-level constructs on top, because after all, F is going to equal MA whether you believe it should or not. Next, it needs to scale. We want solutions that are industrial strength and that will scale to the real-world requirements of real-world applications. We don't want to build something that's awesome for Hello World, but then it's going to collapse the first time it bumps into the messy complexities of reality. And finally, reach. For this problem, for making it easier for you to write Android applications the right way, what we think is the right way, we want to use libraries like SupportLib wherever possible, rather than adding new APIs to the platform, because that lets our solution reach older versions of the OS as well. OK, so that's the background on what we're trying to accomplish and why we're here. Now I'd like to introduce Yeet, Toolkit Engineer Extraordinaire, and he's going to walk you through what we actually built. Thank you.
Thanks, Mike. Hello, everybody. So, OK, that was the background. What are we shipping today? The very first thing we are shipping is an architecture guide on developer Android.com. Now, for over years, you've been asking us for our opinion, like how do we think then an application should be built? And this is that guide. So we believe that is a very good, covers lots of application cases. But even if you have an architecture that you are comfortable with, you can keep it, but you can probably learn something from this guide. Second, we are shipping a new set of libraries that we call architecture components. These are more fundamental components where you can build your application on top. The first thing is lifecycles. So this is the biggest developer complaint we have. Lifecycles are hard. Lifecycles are hard. And we say, OK, we should solve this problem. And the first level of this new set of components. Second one is lifecycle-aware observables, which we'll go in detail later. But this is basically things that can do something based on the lifecycle. Third, we are going to introduce a lightweight view model, which is all of our effort to take out that code outside of your activities and fragments and put it somewhere else where you can easily test it. Last but not least, we are going to introduce a new object mapping library for SQLite. And all of this is available for you today on MavenGoogle.com. OK. Let's talk about lifecycles. So what's hard about lifecycles? Why do we hear so many complaints about that? Let's go through an example. Assume we have an activity where we want to show the location of the device on the screen. So you'll write something like this. You create a location listener on create method. You need to initialize it with the context. Then you have a callback that it calls whenever the location changes. And then you update the UI. Now, if you have ever written an Android application, you know that this code is never enough. You also need to go ahead and override on start and then tell it to start, and override on stop and tell it to stop. You always need to do this babysitting for these components. But this is acceptable. This is a simple example. This looks all right. But then your product manager comes and says, oh, you know what? We need to first check the user settings before asking for location. Then your developer says, OK, sure, that's an easy change. I'm going to change this method to first call this utility method, which probably makes a web service call to check the user settings. And then if the user is enrolled, then we want to start the location listener, which looks like a very simple change. You will think this would work. But let's look at what happens in that activity's lifecycle. So our activity was created. We said, OK, when start, check if the user's status is enrolled. Then meanwhile, user wants to rotate the device, which rotation means a configuration change, which means Android is going to recreate that activity. So in onStop, we knew about this, and we said, OK, location manager, stop. And then the new activity came. It also goes through the same thing. Looks all right, except, do you remember this call we made before? That little change, and then it decides to come back. Hey, users enrolled. And then what we did, we said, OK, then start. Now you realize the bug. We called start after calling onStop, which means our activity will live forever. We are going to observe the location forever. The battery will drain. We will have sad users. This is a situation, right? We want to get rid of this. We want to put an end to this. So we said, OK, we need to acknowledge, like as Mike mentioned, we cannot change the laws, but we can make it easier to deal with these things. So we decided to introduce a new interface called Lifecycle Owner. This is a thing with a lifecycle. Is your activity, is your fragment, or maybe you have your own UI framework, whatever the container you have there is a lifecycle owner. And we have these lifecycle observers, which are the things that care about the lifecycle. Like the location listener we had, it cares about the lifecycle. It wants to stop itself if the lifecycle is not active. So we said, OK, we will acknowledge this, and we have lifecycle observers. I will go through our activity. Now we make our activity extend the lifecycle activity class. This is just a temporary class until these components reach 1.0. Then everything in support library will implement this lifecycle owner interface. Inside our activity, when we initialize our location listener, we are going to tell it this is the lifecycle you care about. And that's all we will do. The rest is the same. It calls back. We update the UI. So how can we change our location listener to take advantage of this lifecycle? Oh, we do the same thing for the user status as well. OK. So there's some boilerplate code here to get the fields. It doesn't really matter. But we have this enable method, which gets called if the user is enrolled. Inside this enable method, now we want to start listening to location only if the activity is started. Now you can do this. You can say, what is my current state, which is amazing. We didn't have this API until now. But now you can. So OK, that was a simple change. But we also get notified. What if we get enrolled when the activity was in the backstack and user comes back to the activity? Now we should actually start the location manager. For this, we want to observe that lifecycle. To do that, we implement this interface, which allows us to write these methods. You can annotate a method saying that if onStart happens, call this method. And the new components will take care of calling it. So if you are already enabled, now you start. And on stop, you disconnect. And last but not least, if the activity is destroyed, there is nothing you want to do with that activity, so you can unregister. So now you might be asking yourself, well, you just moved those onStart, onStop methods from the activity into this location manager. Like, how come it is simpler? It's simpler because those methods live in the right place. It's the location manager which cares about the lifecycle. So it should be able to do it without the activity babysitting itself. Like, I'm sure if you look at your code today, your activity onStart, onStop methods are like at least 20, 30 lines of code. We want them to be 0 lines of code. If we go back to activity, I want to point out something that, look, in onCreate, we initialized these components, and that's all we did. We didn't overwrite, we didn't onStop, onStart, we don't overwrite any of those things because the location manager is a lifecycle-aware component now. So it's a new concept we want to introduce. A lifecycle-aware component is a component that can get a lifecycle and do the right things. It can take care of itself so that in your activity, you can just initialize it and forget about it. You know that it's not going to leak you. Now, of course, it was like more of moving the complexity from activity to the location manager, and then it still needs to deal with lifecycle. We said, OK, what do we want? It's nice to be able to do that, but we want more. We want like very convenient to handle this common case. It's very common that your activity or fragment, it observes some data, and whenever that data changes, it wants to refresh itself. Like it happens basically almost every single UI. And we want to share resources across multiple fragments or activities. Like the location of the device is the same from fragment to fragment. If you have 2 fragments, Why do you need to create two listeners to listen to the same location? Hence, we created this new live data class. Let's look at that. So live data is a data holder. It just hosts some data. It's like an observable. But the tricky thing about live data is that it is lifecycle aware. It understands about life cycles. Because it understands about life cycles, it automatically manages subscriptions. So very similar to the previous example, if you are observing a live data, you don't need to unsubscribe. The right things will happen in the right times. So if that location listener was a live data and a singleton, because location is singleton, we could write the code like this, like get the instance, start observing. And when you observe, you say, this is my life cycle. This is all you need to do. Before on Android, if you were observing something singleton from an activity, everyone will give like -2 to that code review. Now you can do this. This is safe. Nothing ever leaks. So if you want to change our location listener to use this new API, we get rid of all the unnecessary things. All we need is a context to connect. But we say, this is a live data. This is a live data of a location. And we get these two new methods. One of them says on active, which means you have an active observer. And the other one says on inactive, which means you don't have any observers that are active. Now at this point, you're probably asking yourself, what is an active observer? Now we define an active observer as an observer that's in the started or resume state, which is like an activity user is currently seeing. So if you have an observer in the backstack, there's no reason to code this inactive. Like there's no reason to update that activity because user will never ever see what's going on there. So inside our connect method, all we need to do is whenever the system location manager sends us a new location, we call set value on ourselves. Then the live data knows which are the active observers and delivers the data to those observers. Or if one of the observers was like on the backstack and then becomes visible again, live data takes care of sending the latest data back to that observer. And then we can make our location listener singleton because, well, we don't need multiple instances. So if you look at live data, it is a lifecycle aware observable. It has very simple start and stop semantics. Doesn't matter how many observers you have or what state they are. We merge all of it into one lifecycle. And it doesn't have any activities or fragments inside it, but it works with both of them. And it's also very easy to test live data because it's kind of Android free. And if you know about this like infamous fragment transaction exception, we guarantee that your observer will never ever be called in a state where you cannot run a fragment transaction. So this is very, very specifically designed to work well with your activities and fragments. OK, let's think about configuration changes. Now, that example was easy because location is global, but most of the time, the data belongs to a UI. So if we had an activity where we show a user profile, and we implemented a web service that can return the data as a live data, which we can safely observe without risking leaking our activity, this all looks nice. You will never leak this activity. It will work very well, except what happens if the user rotates the device. Let's look at the lifecycle graph again. So activity is created. It says, OK, fetch the user. And then while you're fetching the user decides, oh, I want to rotate the phone. And then that activity is destroyed. Luckily, we don't leak it, which is great. But then the new activity starts, which makes this new call. Now, this is OK, but not great. What do we want? We want to actually retain that data, right? We're already making that request. Why remake it? So we want our graph to look like this. So if the new activity comes, we should be able to give it back the same vModel, which is a new class called vModel. So we are introducing this new class very specific to this thing, where you should put the data inside your activities into the vModel and make the activities data-free. So if you want to change this activity, we create this new class. It extends the vModel class. Whatever data we had inside the activity, we move it there. And in the vModel, all we do is, inside the getUser method, if this is the first call, get it from the web service. Otherwise, return the existing value. Now, it's super simple. And inside our activity, we get rid of all that code. We say, get the vModel providers of this. So each activity or a fragment has a vModel provider that you can obtain, and that vModel provider knows how to give you the vModel. So when you call get my vModel, the very first time you make this call, we will give you a new instance. When the rotated activity comes back, it's going to reconnect to the same vModel. And then the rest of the code is the same. So if you look at the life cycle, this is how it looks. This is what we wanted. The new activity is started. It reconnects. And when the new activity is finished, like when we don't have anything to do with that activity, and then we go and tell vModel that it's not needed anymore. This is actually the only method in the vModel class. So it's very simple. So if you look at life cycles, they hold the data for the activity. They survive configuration changes. They should never, ever reference views because they outlive the activity. So you cannot reference back to the activity. That's why you use things like live data or RxJava or data binding observables to do that communication. And this is what our activity talks to. It always talks to a vModel. Now, another big topic is persistence. Now, we know that to write a good responsive Android app, you need to save the data on disk. If you come to Android, there's these three major APIs we have. One of them is content providers, which is to talk between processes. It really has nothing to do with persistence in reality. The other one is shared preferences, which saves the data in XML. So you can only put very little data into that. And the last one is SQLite, which is something we have been shipping since Android 1. So you need to use SQLite if you want to save big data. And so you go into the developer Android.com. This is the very first saving your data slide. This is so confusing. This is very sad. So we said, OK, we want to make this less sad. We want to make it happy. So we look at the example, right? So there's on top, it tries to say, I want to select these 3 columns with this constraint, and I want to order them like this. It's actually a very, very simple SQL query, but you need to write all this code. Plus, this code doesn't even show where you define all those constants. So what do we really want? We want to get rid of that boilerplate free code. When you are writing Java, if you make a typo in Java, it doesn't compile, right? We want the same thing for SQL. We still want to use SQLite because on every single Android device, it's a proven technology. We know it works very well. But we want the compile time verification. So we don't want the boilerplate code. We want the compile time verification. So we said, well, we came up with Room, which is an object mapping library for SQLite. So if you look at this query, we said, OK, let's move this query inside the annotation. We like annotations. And we have this feed object, which we want to save in the database. I want to put that query inside an interface. Like you want to create the feed DAO. The DAO stands for Data Access Object. Usually in database, the best practice to put your database access into certain interfaces. Then we just need to tell Room, this is a DAO. Tell Room, this is an entity. And finally, we had a database class which says, I have these entities, so you have multiple entities, and I have these data access objects. This is all you write. Once you write that, you can get an implementation of it from Room. It's very similar to how you use Retrofit or Dagger. You define the interfaces, we provide the implementation. Now, once we know this is a DAO, well, we can do these shortcut methods like insert these items or delete these items or update, like a bunch of shortcut methods, and you can pass multiple parameters. As long as you can read it and it makes sense, Room will understand it. But the most important part of Room is it understands your SQL. So the part like all those constants I mentioned we defined to get compile time guarantees, Room actually gives all of this for free. So when Room sees this query, it says, OK, you are receiving these 3 columns from this table where the title looks like this keyword. Where is this keyword coming from? Oh, it's coming from the function parameters. Makes sense. And what does it want to return? It wants to return a list of feeds. And then Room goes and checks. Does the columns returned match the object the user wants to return? And once they're equal, it says, OK, I can generate this code. You can even say select star. Like you don't need to list them. Room really, really understands your query. You can even like join 10 tables, it will still work. But what if you made a typo? Instead of saying feed table, you wrote feeds. Now, if this happens, Room is going to give you an error at compile time. So it goes ahead and verifies your query against the schema you have defined, and it tells you if something is wrong. That's not the only thing it does. So if you say, if your query is correct, you want to fetch ID and title, this is a valid query, but you want to return it as a string, and then Room says, well, you are returning 2 columns, but you only have 1 string, that doesn't make sense, and it's going to give you a compile time error again. And it's a very nice way to fix this in Room. You can basically create any Java class. It doesn't need to be annotating. There's nothing special about that POJO, and tell Room to return it. As long as whatever query returns matches what you wanted to return, Room will write the code for you. And observability, which is very important, right? If you have a query like this, now you're showing list of feeds, you obviously want to get notified when that data changes. And in Room, if you want to do this, all you have to do is tell it to return a live data, and it will do it for you. Because it knows your query, it knows what things affect it, so it can let you know if that query changes. And this is the part where all these architecture components work well together. Room already knows about live data. So in your view model, all you would write is, from the database, call this query, and this all you will do. Whenever that data changes, your UI will get a new update. And it only happens if the UI is visible. Last but not least, Room also supports RxJava 2. OK, if you look at Room in a nutshell, it writes the boilerplate code for you. It has full SQLite support. You can just write any SQLite. There's no builders. It verifies your queries at compile time. It incentivizes best practices, which helps you with testing, migrations, and it's also observable out of the box. OK, architecture, our last topic today. So where we started, right? And now you might be asking yourselves, what has changed in 2017 that you're talking about architecture? Well, actually, nothing has changed. We've been talking about this topic a lot. Adam Powell and I gave a lot of talks on this topic. There's even a talk from 2010, which I watch as a developer. So this is a topic we have been vocal about, but what is missing was a well-defined reference architecture. So it's what we are shipping today. If you go to developerandroid.com today after the session, there's a section about how to architect an Android application. So by the way, this is a reference guide. This is not your religious book. We believe this is a very good way to write applications, but you don't need to follow it line by line. So I'm going to briefly go through this architecture, but if you get lost, don't worry. We have all of this documented on developer.com with sample applications. So we think that an application is composed of 4 main things. There's UI controllers, the view models, a repository, and the data sources. So let's look at these in detail. UI controllers are your activities, fragments, custom views. They have very simple tasks. They observe the fields of the view model and update themselves. And they have one more responsibility. Whenever a user takes an action on the UI, they understand that action and call the view model to express whatever the user wanted to do. If you go to our view model is the one which prepares the data for the UI and holds on to it. This is where the data for the UI lives. View model knows how to get that data. Usually, it has like live data. If you're using RxJava, it has observable or data binding observables. It survives configuration changes. That's why we put the data into the view models. And it's also the gateway. You can also consider it as your UI controller only ever talks to the view model to reach to the rest of the application. And then what's the repository? Now, the view model serves as a data store for your UI controller, right? Repository saves as a data store for all of your application. So it's the complete data model for the app, and it provides this data with simple APIs to the rest of the application. Like you can have a user repository where you pass a user ID, and it returns you a live data of users. How it gets the data, you don't care. It's the repository's job. So how does it do that? It talks to the fetching, syncing, looking at database, or talking to your retrofit backend is the repository's job. And last but not least, we have our data sources, like your REST API client, you might be using retrofit, or you have SQLite storage, you might be using Room, or you might be using Grand, doesn't really matter. Or you might be talking to other content providers from other processes. These are things we call data sources. And we think that all of these layers can discover each other through a dependency injection system, which we recommend using Dagger. But we also realize that understanding dependency injection is not very trivial, like it's a more complex topic, and sometimes it might be an overkill. And you can also use a service locator if you feel more comfortable with it. So let's go through a concrete example. Let's say we have a UI that shows a user profile, and we have the data sources which, we save it to database, we also can get it from the network. How do we connect these two things? Well, we said we first need a user repository. User repository knows it should check the database. It's not there, make a web request, or meanwhile also turn on the database. It doesn't matter how it does it, but it knows how to create a live data of a user, or unobservable, doesn't matter. And then we need the vModel, right? Because the data for the UI lives in the vModel. So we create this profile vModel, which talks to the repository to get this information, and then the actual fragment gets the data from the vModel, so that if the fragment comes back, the live data will be there in the profile vModel, but if the fragment disappears completely, we will get rid of the vModel, and the data can be garbage collected. Now, all this abstraction we made, if you notice, every single component only talks to the one right below it, which helps you scale your application. It also has a great side benefit, which is called testing. You're testing, right? No. So let's say you want to test your UI. Now people say UI testing is hard. UI testing is yes, it's harder, but it's usually hard because you put all of your code into that activity. Now we said put most of it into the vModel, and you know that the UI only talks to the vModel, so you can get rid of the other two. You only need to create a fake vModel to test your UI. Testing your UI becomes super, super easy with Espresso. And we have a sample app on GitHub that you can check how we test the UI. And the same thing is valid for vModels. If you want to test the vModel, you know it only talks to the repositories. You replace it with a mock repository, and it works. And you can even test your vModels on your host machine, on JVM. And last but not least, you can test the repository the same way. You just mock the data sources. You can easily test your repositories as JUnit tests. Now, I know this has been a lot of information. We have 2 sessions tomorrow and lots of documentation. But now I want to call our product manager, Lucas, to talk about what to do next.
Like Yeet said, we just covered a lot of ground, and actually we glossed over a lot of detail while we did that. But luckily, you don't have to remember everything that you just heard. We have a lot of material for you to check out at developer.android.com/arch, and that link should start working in 21 minutes. We wanted to give you guys a chance to kind of blog and tweet about this before anybody else, so that's why we held it back. So yeah, we made having good documentation and samples a priority from the beginning of this project, since providing good guidance is really one of the major goals. So you're going to find in-depth documentation that's written from the perspective of an app developer. You're going to find really meaty sample apps that show how to build a real app. And just as an example of how much work went into this, we have a GitHub browser sample app that probably has better test coverage than many real-world apps, written by that guy. And of course, we have the guide to app architecture, which internally we called the opinionated guide for a while. And we think that label still applies. But even if you're not planning to use our recommended architecture, we think people should check out the guide. It has principles that we think apply to all apps on Android. And you're probably asking yourself, do I not, what's the impact of this going to be on me? Am I going to have to kind of like change the way that I'm doing everything? If you're starting a new project, or if you have an existing app but you want to improve the core architecture, then yeah, we recommend taking a look at this stuff. It's still preview. We won't be hitting 1.0 for a few months, but we think it's definitely ready for you guys to check out and use in projects. But if you're happy with what you have, you don't need to rewrite your app. So in the spirit of be together, not the same, we're not dictating what everyone has to use. If you're happy with your app architecture, you can keep it. If you're happy with your existing ORM, you don't have to use Room. Architecture components are designed to work well together, but they do work perfectly fine standalone. And mixing and matching applies not only to architecture components, but also third-party libraries. So, waiting for the slide to come up. So you can kind of use what you have and to start to integrate architecture components where they make sense. So, for example, if you're happy with RxJava, but you really like the lifecycle-aware component stuff that you just showed, so that you have these kind of like self-sufficient components, you can use live data together with RxJava. So you can get all the power of RxJava operators, and now it's lifecycle safe, so kind of the best of both worlds. And we've got additional integrations to come. We're definitely looking at a lot of stuff internally that would be nice if it were kind of like self-sufficient and lifecycle aware. And if you're a library developer, we really recommend checking out Lifecycles and Lifecycle Observer because we think there's a really bright future and a lot of potential in making libraries and components that are lifecycle aware by default. But before you go do that, we have a lot more for you at I/O this year. We have 2 more talks, one on life cycles that's even more in-depth than what we just showed tomorrow morning. We have another one on Room and persistence, and going a little bit beyond Room, starting at 12:30 tomorrow. And we'll have people who are kind of well-versed in architecture components in the sandbox for all of I/O. And we also have code labs, which we're pretty happy with. And there's more to come. So we think we've just scratched the surface of ways that we can improve the experience of using Android frameworks, and we're looking to applying this approach in other areas as well. So some things are already in the works, and we're also interested in hearing from you on kind of what else you'd like to see. So come by, talk to us, tell us what you like, what you don't, and stay tuned because we're really excited about the future of Android development. Thank you.